Hello, Miss Thinker here. Your daily source for mind-blowing facts, forgotten history, and powerful motivation. What if time travel isn't science fiction, but real science? Not in a movie, not in a fantasy, but in actual space, scientists have already proven that time can slow down, stretch, and even move differently depending on where you are in the universe. So the real question isn't, can time travel exist? It's this: are we already doing it? Most people imagine time as constant, ticking forward at the same speed for everyone. But according to physics, that's not true. In 1905, Albert Einstein discovered something revolutionary: time is flexible. His theory of relativity showed that time can slow down, speed up, stretch, bend, depending on motion and gravity. This means time isn't universal, it's personal. Two people in different conditions can experience time at different speeds. This might sound unbelievable, but time travel already happens, just in very small amounts. Astronauts aboard the International Space Station actually travel slightly into the future. Why? Because they move extremely fast, about 28,000 kilometers per hour. At that speed, time for them slows down compared to people on Earth. After months in orbit, astronauts return having aged tiny fractions of a second less than everyone else. It's not dramatic time travel, but it's real, measurable, and proven. The faster you move, the slower time passes for you. This effect is called time dilation. If a spacecraft could travel close to the speed of light, something incredible would happen. Years could pass on Earth, while only days pass for the traveler. For example, if someone traveled at 99.9% the speed of light for 1 year, they might return to Earth hundreds of years in the future. They wouldn't feel anything unusual. To them, only 1 year passed. To everyone else, centuries passed. That means traveling forward in time is not only possible, it's predicted by physics. Speed isn't the only thing that affects time. Gravity also changes it. The stronger the gravity around you, the slower time moves. Near extremely massive objects like black holes, time slows dramatically. At the center of our galaxy lies a supermassive black hole called Sagittarius A*. Near an object like this, time could slow so much that minutes for you could equal years far away. This effect has actually been measured on Earth using precise clocks at different altitudes. Clocks closer to Earth's gravity run slightly slower than clocks higher up. This isn't just theory, it's been experimentally confirmed many times. Even satellites launched by NASA must adjust their onboard clocks to account for time dilation. If they didn't, GPS systems would quickly become inaccurate. So every time you use GPS on your phone, you're relying on corrections based on relativity, proof that time really does move differently depending on speed and gravity. Traveling forward in time is possible, but what about backward? That's where things get complicated. Physics equations allow for strange theoretical structures called wormholes, closed time loops, warped space-time tunnels. In theory, these could connect two different points in time. But there is a problem. They would require exotic matter, a substance with negative energy that scientists have never discovered in usable form. So backward time travel remains purely theoretical for now. The biggest barrier to time travel isn't physics. It's technology. To meaningfully travel into the future, we need spacecraft capable of near-light speed travel, something far beyond our current engineering abilities. But the laws of the universe don't forbid it. And that's what makes this idea so fascinating, because it means time travel isn't magic. It's science we just haven't mastered yet. Time isn't a straight road. It is more like a cosmic river, flowing at different speeds depending on where you stand and how fast you move. Somewhere in the universe right now, this brings us to the most famous puzzle of backward time travel, the grandfather paradox. Imagine you travel to the past and prevent your grandparents from ever meeting. If they never meet, you are never born. But if you were never born, you couldn't have gone back in time to stop them in the first place. It's a loop that has puzzled scientists and philosophers for decades, questioning if the past is truly unchangeable. One possible solution is the multiverse theory. This idea suggests that every action or decision spawns a new parallel universe. So if you went back and stopped your grandparents from meeting, you wouldn't erase your own existence. Instead, you would simply create a new timeline, a new universe where you were never born while your original universe remains untouched. Time travel in this view becomes a form of universe hopping. Then there's the quantum world, where the rules of reality get even stranger. At the quantum level, particles can exist in multiple states at once, a concept called superposition. Some physicists believe time itself might behave this way, existing as a cloud of possibilities until observed. This could mean the past isn't set in stone and the future is a vast, unwritten landscape of potential moments. Let's explore the bootstrap paradox. Imagine a scientist travels to the past to give a young Shakespeare a copy of Hamlet. Shakespeare copies it and it becomes a classic. The scientist then picks up that same copy centuries later to take it back in time. The question is, who actually wrote Hamlet? The book exists in a loop with no discernible origin. Now let's dive deeper into wormholes. As we mentioned, these are theoretical tunnels through space-time. If one end of a wormhole could be accelerated to near the speed of light and then returned, time dilation would cause it to age less than the stationary end. This would create a time difference between the two ends, potentially turning the wormhole into a gateway to the past. This brings us to the ethics of time travel. If we had the power to alter history, should we? Could we prevent a disaster, or would our actions create an even worse future? This is the moral minefield of time travel. Every change, no matter how small, could have unforeseen consequences, rippling through history in unpredictable ways. The responsibility would be immense. Finally, let's consider the arrow of time. Why does time only seem to flow forward? This is linked to the concept of entropy, the idea that the universe is constantly moving from order to disorder. A broken egg never spontaneously reassembles itself. This one-way street of increasing entropy gives time its direction, a constant, irreversible march from past to future. But what if paradoxes are impossible? The Novikov self-consistency principle suggests that. It argues that any event that happens in the presence of a time traveler was always meant to be. In this view, you can't change the past because your actions are already part of it. You are altering history. You are fulfilling it. Free will becomes an illusion, and the timeline is a single, unchangeable path. Let's consider Tolkien's hypothetical particles that travel faster than light. According to physics, if they exist, they would move backward in time. This opens the door to sending information to the past, creating what's known as a causal loop. You could send a message back in time to prevent an event, but that prevention would mean the message was never sent in the first place. It's another paradox that challenges our understanding of cause and effect. Finally, let's turn inward to the psychology of time perception. Why does time seem to fly by as we age, yet slow to a crawl during a crisis? Our brains process time based on the amount of new information we receive. When we're young, everything is new, so our brains record more data, making time feel longer. In a life-threatening moment, our senses are heightened, and we absorb more detail, stretching out the seconds. Time, it seems, is not just a physical dimension, but a mental one as well. Time is passing slower, somewhere else. It's racing ahead. And someday, humanity might learn how to navigate that river, not just through space, but through time itself. If you enjoyed this journey through the science of time and space, subscribe for more real cosmic mysteries, mind-blowing discoveries, and the secrets of the universe explained simply. Because out there, time is stranger than we ever imagined.